Okay, we're going to talk briefly today about similar polygons. Now, we talked a little bit about this on Friday, and I think you've heard of this before, so it should be pretty easy. So similar polygons, you can write this in your vocab if you have it out, are two polygons such that their corresponding angles are congruent and the lengths of the corresponding sides are proportional. A scale factor is just the ratio of those corresponding lengths to the sides of the similar polygons, and we'll talk about that. Let's look at this first example. Quadrilaterals ABCD and EFGH are similar. They tell you that they are. First, they want you to write a similarity statement and then list all the pairs of congruent angles. Then, write the ratios of the corresponding sides. All right, so let's first start the similarity statement is just this, that ABCD is similar to EFGH. And just like when we did triangles, the order in which you report the vertices, so if you put A, B, C, D, is important because you are going to be looking at corresponding sides, and that order is going to be very important. So just be mindful of that. Oh, I'm supposed to put that down here. Okay, let's talk about the congruent angles. So according to our similarity statement, A is corresponding with E, so those must be congruent. Angle A is congruent with angle E. Angle B is corresponding with angle F. Oops. And then if we keep going, angle C is corresponding with angle G. So that means that they're congruent. And then angle D is corresponding with angle F. So that means they are congruent. Okay. Statement of proportionality is just where you list off all the sides that are proportional. So if I go through my quad, side AB, don't really want that. Side AB is proportional to side EF, so we can write that. And we can write that statement for all of the sides. So BC is proportional to FG because they're corresponding. And CD is proportional to GH. And then last side, DA is proportional to HE. All right, so the reason why I set these all equal to each other is because we know that the ratios of the corresponding sides is congruent. All right, let's look at our example 2. In example 2, they ask you to decide whether the figures are similar. If they are, then write a similarity statement. So in a part A, first thing I might look for is if all of the corresponding angles are congruent. And it looks like I've got two angles that are 45. I'm going to look on this triangle right here to see what my third angle should measure. So if I subtract 54 and 45 from 180, I get 81. So now I have to ask myself if this is a case where all my corresponding angles are equal. And it's actually not, because there's no way for you to have all corresponding angles equal if you have this angle here that's 90. All right, so these are not similar. Let's check part B. So first let's check for the angles. It looks like they have marked A and H are congruent, E and G are congruent, F and D are congruent. So that's 3 of the 5 angles that I know are congruent. If I look here, angle B and angle J are also marked 100. So those are congruent. Now, I've got 4 of the 5 angles are all congruent, which means, using your logic, that the fifth angle is congruent on both as well. So I'm going to just take note of this, that corresponding angles are congruent. What I don't know is if the corresponding sides are congruent. I need to show that. So I'm going to start by looking and comparing the sides. So I might start with side AB. Side AB is going from the angle that has 1 tick mark to the angle that's marked 100. So I'm going to do that same thing on my larger quad over here, and that's H to J, which is 3. So I'm going to just jot this down. I know that my ratio is 2/3 for that corresponding pair of sides. I'm going to go and I'm going to check for each pair of corresponding sides to make sure that the ratio is the same throughout the whole thing. So if I go then from B to C, I'm going to be going from J to K. So that's 6/9. And then if I go from C to D, K to F is 3/4.5. And then 5/7.5. And then lastly, 2/3. Okay, so if you had a calculator and you checked, all of these are equivalent. They're all 2/3. So that's good news. We can say for sure that our corresponding sides are proportional. Okay, so yeah, these are similar. So let's write a similarity statement. Quad ABCD is similar to quad, make sure you get the order right, HJKF. Oh, I'm forgetting letters here. Let's try this again. ABCDE is congruent with quad 1, 2, 3, 4, 5. This isn't a quad. Sorry, I've been calling it a quad. It's a 5-sided figure. Okay, so HJKFG. There we go. All right, now let's talk a little bit about scale factor. So scale factor, let's look back at our vocab, is just the ratio of the lengths of two corresponding sides in polygons that are similar. So in this one, I want to look for a scale factor in this first one right here. I want to look for a scale factor from ABCDE to HJKFG. Now what that's doing is it's going from the smaller to the larger. So you can just use your proportions that you found before in the ratio of the side lengths. The scale factor from the smaller to the larger is 2 to 3. If you're going to go the other direction, larger to smaller, you can just flip that, 3 to 2. All right, last example. In this example, you are told that the polygons are similar. You don't have to show it. You just need to find the value of x is what they want. So for part A, they tell you that ABCD is similar to WXYZ. What that means is that the length AB is proportional to the length WX, which is 8, and that proportion must be equal to the ratio of AD, which is 14, to WZ, which is 10. And notice how both times I made sure that I put the same lengths, the same side lengths on top. Like I put X and 14 on the top of my two ratios here, which were both coming from my figure on the left. Okay, you can put either side lengths on top if you want. Like if you wanted to put the 8 and the 10 on top, that would be fine. Just make sure that you are staying consistent, that if you are putting, you know, the longer length on top on one side, then you need to put the longer length on the top on the other side. All right, so solve this proportion. We've been practicing that a little bit. So we've got 10x is equal to 112. So x is 11.2. All right, let's look at this one. This one's a little bit trickier. Okay, so they tell you that JK, whoops, that's not JK. JK is proportional to the length PQ. We're going to go through this. And then KL is the next side length, which that's QR. And then LM, okay, here they tell you LM is 7, and then RS is just this marking. Okay. So I'm gonna use the 7, but what I don't know is what the corresponding side length on the other figure is. But notice that this has 2 tick marks, this RS has 2 tick marks, along with PT over here, which is marked X. So I know that RS is really just X. So I'm going to use that in my proportion here. All right, so if I keep going, MN has a side length of 3, and ST has a side length of 6. So I've got all I need here to solve for X. So 42 is equal to 3X, so X is 14. Okay, really quick, let's talk about the scale factors here. On part A, notice that the first part, you need the scale factor from ABCD to WXYZ, which is the larger to the smaller. So I can just write one of the pairs of corresponding side lengths and then just simplify that. So that's just 7 to 5. And then if you want to go from smaller to larger, you can just flip that. All right, and then on the one on the right, we need the scale factor from the smaller to the larger. So I know that one of my corresponding sides was 3 to 6. So that's smaller to larger, and you're going to simplify that 1 to 2. And then if you go from the larger to the smaller, you can just flip that. Okay?